Hi, we are team number 15 and we are composed by Alejandro Vera, Seth Mongbeh, and Meza. For this project, we were assigned to design a gearbox that will transmit at 2 horsepower with an input speed of 420 RPM and an output speed of 30 RPM. Also, our input and output shaft has to be were required to be parallel and aligned, and both of them have to rotate in the same direction. So we designed a gearbox using spur gears because they are the most commonly used and they have a good performance. Our design is going to use 4 gears located like this, to here in the first stage, and to here that will make the second stage. So that we only have 2 stages, therefore our gearbox can be very small. We also have a 3 shaft located like this, and 4 bearings located next to each gear. All gear, shaft, and bearing were chosen using the correct process. For example, for the gears, we pick a gear from Boston Gear catalog, remembering that the sum of the diameter of the gears from the first stage has to be equal to the sum of the diameter of the gear from the second stage, so that our shaft can be parallel and aligned. So we picked these 4 gears. For the first stage, we're going to have a 20T gear and an 84T gear with a diametral pitch of 10. And for the second stage, we're going to have a 24T gear and an 80T gear with a diametral pitch of 10. All of the gear are made of steel. The gear number 2, gear number 4, and gear number 5 could be found on the Boston Gear catalog. But the gear 3, we couldn't find that gear on any other catalog, so we did contact some companies that make custom gears, and they can make that gear.
Good afternoon, my name is Alejandro Vera, and I'm going to talk about the gear design process. After selecting the gears, we use the ADMA equations to calculate the factor of safety for each stage. For the first stage, we calculated the pitch velocity and then calculated the load, and it came out to be 300 pounds to be transmitted. We used the ADMA equations to calculate the factors of safety. We calculated the factor of safety for the pinion on bending to be 4.33, and the factor of safety for the gear and bending to be 6.33, meaning that they're really good. For the contact stress, we calculated the factor of safety to be 1.79 for the pinion and 3.2 for the gear, which is also really good. After comparing both factors, all the factors of safety, we came out to the conclusion that the pinion thread is from wear and the gear thread is from bending. We did the same thing for the second stage. We calculated the pitch velocity, we calculated the load. The load this time came out to be higher, was 1,050 pounds. We also calculated the factors of safety. For bending for the pinion, it came out to be 1.316, and for bending for the tooth, for the gear, it came out to be 1.458. They're really good as well. Then we calculated the factors of safety for the contact stress, and it came out to be 1.061 for the pinion and 1.76 for the gear. Comparing the results, we came out to the conclusion that the thread in the pinion is from wear, and the thread in the gear is from wear as well. After that, we also did the design for the bearings. For the bearings, we split it into 3 parts: shaft A, shaft B, and shaft C, each of them with different RPMs. We calculated the forces being transmitted, we calculated the design life, and then we calculated the design, the C10, to then go in the catalog and choose the appropriate bearing.
Hello. My task was finding gear prices online, bearing prices online, and shaft prices online. After extensive research, we found that the price ranges for gears around $15 to $30. For shafts, we found a higher price of $300 to around $1,200. But for our design, Gear 3, we couldn't find in any catalog. So we had to go to rushgears.com and order a custom gear. That came out to about $2,000. So our estimated total for our gear system is about $2,060. Team 15's applications. Our gear system was used to reduce engine rotational speed as well as increase torque. This can be seen mostly in machine lifts and transmission systems for small machinery. At the end of the project, Team 15 did pretty good. All the factor safeties were above 1.0, so they all were positive. We found all of our components in commercial gear catalogs, which our professor called for, and we found the estimated cost for all of them. So, thank you for watching.